Good morning, class. Here's Module 3 covering chapters 5, 6, and 7. In section 6.3, inverse trigonometric functions, chapter 7, trigonometric equations and identities. Here's the pledge when we take the exam. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam for that matter. Unauthorized actions include but are not limited to the use of notes, text, graphing, calculators, all the way to AI. I can't emphasize this enough. In other words, we take the exam on our own. All right, so inverse trigonometric functions. So first, reminding you of a couple of things as far as the inverse functions are concerned. Recall, only one-to-one functions have inverse functions. In that case, f of f inverse of x equals x. X is in the domain of f inverse, the inner function. Okay? F inverse of f of x equals x. X is in the domain of f of x. Again, in this case, f of x is the inner function. The domain of f of x is the range of f inverse, and the range of f of x is the domain of f inverse. In other words, domain of one becomes the range of the other. The graph of f of x and f inverse are symmetric, but the line y equals x when graphed on the same axis. So if you use the same set of axes, they are symmetric with respect to the line y equals x, because x becomes y becomes x. That's a general statement. Now, composition of inverse function says f of f inverse is always x as long as it's in the proper domain. In this case, the domain of f inverse. In this case, the domain of f. Now, what about trigonometric functions? We are interested in finding the inverse sine function. As you know, none of the trigonometric functions are one-to-one because they fail the horizontal line test. So when y equals sine x and the domain goes from negative to positive infinity, the range is from negative 1 to 1, it is not a one-to-one function. And that's true for each and every one of trigonometric functions. So what do? We restrict the domain such that the entire range is included. So if we restrict it from minus power 2 to power 2, and by the way, the way you restrict it, you try to have it in one shot, okay? Not disconnected, and covering the entire range, then it becomes a one-to-one function. So with that restriction, we have a one-to-one function. In this case, we're going to say y equals sine x. Domain has changed from negative to positive infinity. We restrict it to negative power 2 to power 2. And now the range remains. It must, otherwise it defeats the purpose. Now this is a one-to-one function. Therefore, it has an inverse function. So we say y equals sine inverse of x. By definition means x equals sine y. Domain, x is between negative 1 and 1. Remember, here's the range, here's the domain. Range is from minus power 2, y is between negative power 2 to power 2 because we restricted the domain of sine. X is between the two now. The range y is between the two. So we'll want to graph the inverse. We go with the easy parts, minus power 2 minus 1, power 2, 1, and this is 0, 0. Now, all you have to do, interchange x and y. So for example, this one becomes minus 1 minus power 2. This remains 0, 0 because that doesn't make difference. It's 1 power 2. And if you graph it, now the two functions are inverse functions, symmetric with respect to the line y equals x. And we write y equals sine inverse of x means x equals sine y, as it was mentioned here. X is between negative 1 and 1. Y is between negative power 2 and power 2. The endpoints, by the way, are included. F of f inverse of x equals x. X is between negative power 2 and power 2. Sine inverse of sine x equals x. If x is between negative 1 and 1, sine of sine inverse of x equals x, because the domain must belong to the inner function. In this case, the inner function is sine x. In this case, the inner function is sine inverse. So in short, the restriction of the domain, remember the domain is all real numbers for sine. The restriction of domain will create a one-to-one function and therefore has an inverse. As an example, we want to know what is sine inverse of 1/2. We let it be some variable alpha, beta, gamma, theta. It's your choice. By definition of inverse function, sine of theta must be 1/2. And as you know, sine theta equals 1/2 is a common arc. Theta equals pi over 6. Bear in mind, when we say sine inverse, there is a unique answer. There is one solution. If you look at the equation sine theta equals 1/2 in from 0 to 360 or 0 to 2 pi, it has two answers. Okay. But when we go with sine inverse, because the restriction is from minus pi over 2 to pi over 2, meaning the fourth and the first quadrant. That is the restriction. Now I want to find the exact value of the expressions. As follows: tan inverse of tan of negative 2 pi over 3, and of course one exact answer, no calculators. And let's see how it's going to work out. Reminding you how tan works, okay. Y equals tan x. The domain is from negative to positive infinity. However, x can't be 2n plus 1 times pi over 2 because tangent is sine over cosine. So whatever makes cosine 0 is excluded. And that becomes the vertical asymptote, by the way. So vertical asymptotes, x equals 2n plus 1 pi over 2. In other words, odd multiples of pi over 2. Odd multiple, 2n plus 1 is odd. Odd multiples of pi over 2. So the ranges are real numbers, and it's not a one-to-one function. None of the trigonometric functions, none of them is one-to-one. So what do we do? Restriction. Now, we do the same restriction as we did with the sine, with the exception that the endpoints are not included. Now, this is a one-to-one function. So, y equals tan x. Domain, we restrict it from negative pi over 2 to pi over 2. The endpoints are not included. Range remains as all real numbers. Now, it's a one-to-one function. Therefore, y equals tan inverse of x means x equals tan y. X is between negative and positive infinity. Y is between minus pi over 2 and pi over 2. Now, x is between negative pi over 2 and pi over 2. Tan inverse of tan x becomes x. Remember, this x belongs to the domain of tan x. This is the restricted tan x. And x is between negative and positive infinity. Tan of tan inverse of x is x. This x belongs to the tan inverse, the inner function, which is between negative and positive infinity. Just to see how these things work for this case. Now, when we look at this one, remember, tan inverse of tan x is x. Tan inverse of tan x would be x. If this is between minus pi over 2 and pi over 2. Minus 2 pi over 3, it's not. It's in the third quadrant. So it's the same as pi over 3. So tan inverse of square root of 3, which is pi over 3. So again, understand this is not in the proper domain, mainly minus pi over 2 and pi over 2. So you have to actually, this is a common arc. You have to evaluate it. Remember, one easy way to understand what really happened is that the period for tangent and cotangent is pi. Just add pi. If you add pi, pi is 3 pi over, so let's write it. Minus 2 pi over 3 plus pi, 3 pi over 3. It gives you pi over 3. That's how we should easily figure this out. What about secant? And remember, secant is 1 over cosine. So let's discuss the cosine. Cosine is not a one-to-one function, just like any other trigonometric functions. Y equals cosine x. Domain is from negative to positive infinity. Range is from negative 1 to 1. It is not a one-to-one function. So we want to keep the range and want to make it 1 to 1. And we choose from 0 to pi because this way it's uninterrupted. So y equals cosine x. If we restrict the domain from 0 to pi, the range remains unchanged and it becomes a one-to-one function. Therefore, we write y equals cosine inverse x means x equals cosine. Domain, x is between negative 1 and 1, range, the restriction that we gave to this one, 0 to pi. Therefore, when y equals cosine inverse of x, x is cosine y. When x is between negative 1 and 1, y is between 0 and pi. And if x is between 0 and pi, cosine inverse of cosine x. Remember, this x is the domain of cosine. This one gives you x. If x is between negative 1 and 1, cosine of inverse. This is the domain of the inner function cosine x. That's what cosine inverse. That's why it must work. Becomes x. Otherwise, you have to figure it out. As far as the secant is concerned, if y equals secant inverse of x, x is secant y. Absolute value of x is larger than or equal to 1. Y is between 0 and pi. Y can't be pi over 2. These are the restrictions that we use for secant. As you recall, the range for secant is all real numbers except the numbers between negative 1 and 1. The same thing for secant as well as cosecant. So what is this equal to? We have no idea. Let's give it a variable alpha. By definition of an inverse function means secant alpha must be square root of 2. We may not know what that is, but we do know cosine. Secant alpha is the reciprocal of cosine. So if secant is square root of 2, then cosine must be the reciprocal of that, 1 over square root of 2. And we should know it's the same as square root of 2 over 2 because you can multiply the top and the bottom by square root of 2 over 2. So in other words, if I multiply by square root of 2 over 2, I get this one. Common arc, alpha becomes pi over 3. Pretty straightforward, everybody. We're going to continue. We're going to look at cosine inverse of 1/2. What is it equal to? Let's say alpha, beta, gamma, theta, x. You choose your variable. By definition of an inverse function means cosine theta must be 1/2, which is a common arc, and theta is pi over 3. What about tan of cosine inverse of square root of 3 over 2? We're going to work on this. Remember, this represents an arc on an angle, so let this be something, for example, beta. By definition of an inverse function, cosine beta must be square root of 3 over 2, which is a common arc, and therefore pi over 6. So we want tan of pi over 6. Tan of pi over 6, we know it to be square root of 3 over 3. Cosine of cosine inverse of 1.2. Remember, 1.2 belongs to the domain of cosine inverse. If so, the answer is 1.2. But it's not, it's undefined. Why is that? Because x must be between negative 1 and 1. 1.2 is larger than 1, so that's why it doesn't exist. It's undefined. So again, we wrote the cosine inverse, we wrote the tan inverse. What about cotangent inverse? Y equals cotangent inverse, x is cotangent y, x is between negative and positive infinity. The restriction on cotangent is the same as cosine. The endpoints 0 and pi are not included. Y equals cosine inverse of x means x equals cosecant inverse x. Y equals cosecant y, and cosecant is 1 over sine. So the restriction is just like sine between negative power 2 and power 2. Y can't be 0. That is restricted. And absolute value of x greater than or equal to 1. So we should know the restrictions in this manner. We want to find the exact value of cosine of sine inverse of negative 1/3, and we're going to look at it two different ways. We're going to use circles and triangles, or we can use identities. So we are interested in finding cosine of sine inverse of negative 1/3. Sine inverse of negative 1/3 is some angle, some arc. So we let it be theta or alpha or gamma, which means we now want cosine of theta. That's the meaning of it, everybody. So if that is the case, what does this mean? Sine of theta must be negative 1/3, obviously negative. Now, going back to sine, okay, the sine inverse, the restriction was the fourth and the first quadrant, and because this is negative, it belongs to the fourth quadrant. So theta is between minus power 2 and power 2, the restriction we put on the sine. And because it's negative, remember, the first quadrant, everything is positive, including sine, so this must be quadrant 4. Also, we remember that if it's a unit circle, sine theta equals y. If it's not a unit circle, it's y over r. And because it belongs to the fourth quadrant, in the fourth quadrant, x is positive, y is negative. Therefore, negative 1/3. It's important to understand how you write that. That negative sign can be in front of a fraction bar, can be at top, can be at the bottom. You have to put it where it belongs. Okay. In this case, belongs to y. Y must be negative 1, and r is always positive, by the way. So now we can calculate the x. Remember, x squared plus y squared is r squared. It becomes 2 square root of 2. Here's the reason. X squared plus y squared is 9. So here's the location, the fourth quadrant. P has coordinates x comma negative 1. So x squared plus y squared is 1, r squared is 9, x squared is 8, and x is plus minus 2 square root of 2, because 8 is 4 times 2, and we choose the positive one. In other words, this is one way to look at it. If you look at the triangle here, here's 3, here's 1, makes it negative 1. Here's 2 square root of 2. And if we want cosine theta is x over r, or the adjacent over the hypotenuse. 2 square root of 2 over 3. So that would be using a circle, a triangle. You can go either way. By the way, you can always use this one as a triangle and just look at the concept of -1 as below the x-axis. So having said that, let's go with the identities. As you recall, Pythagorean identity, sine squared plus cosine squared is 1. 1 plus tan squared is secant squared. 1 plus cotangent squared equals cosecant squared. So if I want cosine is plus minus 1 minus sine squared under the radical. If I want sine, it's 1 minus sine squared is 1 minus cosine squared, and sine is plus minus the square root of that. We are interested in sine given, we want to find cosine. So sine is negative 1/3, quadrant 4, and cosine is plus minus the square root of 1 minus sine squared. Please understand this is the Pythagorean identity used to give rise to this one. So there are two answers. Now the question is which one and why? Okay, we know it's quadrant 4. In quadrant 4, cosine is positive. Cosine is positive in quadrant 4. So you choose the positive one, only the square root of 1 minus, and replace the sign with negative 1/3. When you square that, you get 1 over 9. 1 minus 1 over 9 is 8 over 9. 8 comes out as 2 square root of 2. 9 comes out as 3. And that's exactly what we got here. Both ways are just as easy. You should be familiar with both methods, everybody. All right, write the trigonometric expression for sine of tan inverse of u as an algebraic expression. So understand that the tan inverse represents an arc or angle. So let it be theta, alpha, beta, gamma, your choice. Therefore, tan of theta must be u, and we are interested in sine of theta. That's the meaning of it. So we're going to look at it from the point of view of identities and also triangles, see how that works. Remember, we have the tangent, and we want to get to sine. And we know cosecant is 1 over sine. So we're going to use 1 plus cotangent squared equals cosecant squared, because cosecant will give you the sine, cotangent, tangent will give you the cotangent. They are reciprocal of each other. So cotangent is 1 over u, because tangent is u. Therefore, we are looking for sine theta using 1 plus cotangent squared equals cosecant squared. So 1 plus cotangent is 1 over u, so 1 over u squared, cosecant squared. Left side, the common denominator is u squared. So we get u squared plus 1 over u squared is cosecant squared. If cosecant squared is this, then sine, which is 1 over cosecant, or cosecant, which is 1 over sine squared will be the reciprocal of that. So sine squared is the reciprocal of that, u squared over 1 plus u squared. And so what is sine? Take a root, but you have to take a root with plus minus and then make a decision. We just use the plus. Okay, of course, u squared, we take it out as u. You can rationalize it if you want. Because sine and tangent have the same sign. Remember, the restriction on sine and cosine, both of them from minus power 2 to power 2. And both of them are positive in the first quadrant, negative in the fourth quadrant. So having said that, here's the triangle. Remember, tangent is u, so you can write it as u over 1. You write it as a fraction, because if you're using a triangle, it's the opposite over the adjacent. So you draw a triangle, the angle is theta, the opposite is u, the adjacent is 1, and we don't know this side. We can easily find the hypotenuse using Pythagorean theorem, 1 squared plus u squared under the radical. 1 squared is 1, u squared remains as u squared. And now we are interested in finding sine of theta, which is the opposite over the hypotenuse. And the opposite is u, the hypotenuse is square root of 1 plus u squared. Is pretty straightforward, everybody. All right, let's look at sum and difference formulas, double angle and half angle formulas, how we arrive at it. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And you can look at the proof. We have the proof for those. What is sine of alpha minus beta? Replace this beta with minus beta. So plus minus beta, and it becomes sine alpha cosine beta minus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And again, replace this one with minus beta, and cosine of alpha minus beta becomes cosine alpha cosine beta plus sine alpha sine beta. In other words, you start proving one of them, and then you use the rest of them to prove the new ones. Tangent of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. If I want tan of alpha minus beta, replace plus beta with plus minus beta. So replace that and we get tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. Now double ends. Over here, if I change this beta to alpha, I get alpha plus alpha or 2 alpha. So this is alpha, this is alpha. Sine to alpha becomes 2 sine alpha cosine alpha. What about here? Cosine of alpha plus beta. I'm going to change the beta to alpha. I get cosine of 2 alpha, which is cosine alpha minus sine alpha sine alpha. In other words, cosine squared minus sine squared. Very straightforward. If I change the cosine squared to 1 minus sine squared, I get 2 cosine squared minus alpha. If I change the sine squared to 1 minus cosine squared, I get 2 cosine squared minus 1. If I change this one, I get 1 minus 2 sine squared. In other words, right here, change this one to 1 minus sine squared, then change this one to 1 minus cosine squared, and it creates the following two. So first, just change this one to 1 minus sine squared. You get this one. That's easy to find. Tangent. If I change the beta to alpha, becomes tan of 2 alpha. So tan of alpha plus tan of alpha. So 2 tan alpha over 1 minus tan squared alpha. So I hope you see when we have those, they are easy to come up with. Now, take a look at this one. If I want to solve for sine squared, okay, I'm going to take it to the other side, becomes positive 2 sine squared. I'm going to take this one to this side, becomes 1 minus cosine 2a divided by 2. So I hope you see that sine from here, you solve for sine squared. And now let 2 alpha be, I don't know, x, and then this is x over 2. So the half angle, sine squared of alpha over 2 is 1 minus cosine alpha over 2. This one, solve for cosine squared. Take this one to the other side and divide by 2. 1 plus cosine 2 alpha divided by 2. Now again, 2 alpha, if you replace it with x, then alpha is x over 2. So I will keep it as alpha over 2. What about tan squared is simply sine over cosine. So sine squared over cosine squared, and half of it, tan squared alpha over it. So those are easy to come up with, and you take a root. Tan has 3 different ways of writing it. And for now, that's all that matters, and we will discuss this later on. The point being, you can easily see the proof. All right, we want to use the half angle formulas to give exact values. We don't want any calculators, so sine of 195 degrees. It's half of 390, so it's sine of 390 over 2. And that's plus minus the square root of 1 minus cosine alpha over 2. That means plus minus the square root of 1 minus cosine of 390 over 2. First, we go with plus minus. Then we make a decision to go with positive or negative. And as you know, 195 degrees, it's half of 390. It's in the third quadrant. In the third quadrant, sine is negative. So you choose the negative one. Now, before we change it, remember 390 is the same as 360 plus 30. So it's just the same as 30, right? It's a complete cycle. And cosine of 30 is square root of 3 over 2. And now you have a complex fraction. You're going to multiply the top and the bottom by 2 over 2. First, the bottom becomes 4, comes out as 2. This one, 2. This one is cancels out this one. So square root of 2 minus square root of 3. Don't forget the negative sign. Okay, so what happens here? 15 is half of 30. So cosine of 30 over 2. Why are we using 30? Because 30 is a common arc. So plus minus the square root of 1 plus cosine alpha over 2, that means cosine 30. Now, cosine of 30 is square root of 3 over 2. Are we going to use plus or minus? It depends, because 15 degrees is in the first quadrant. Everything is positive. Same as this one, except this becomes a plus sign and this is plus. So square root of 2 plus square root of 2 plus square root of 3 over 2. That's the answer. Um, I would say try cosine of 15 is cosine of 45 minus 30 in that format also. Different ways of doing it. This is another way of doing it, which is interesting. Using sum and difference formulas, in this case, of course, the difference formula. So, prove identities. Secant 2 theta is secant squared over 2 minus secant squared theta. In order for you to prove identities, there are several ways. One is to go from left to right, one from right to left. One is that from left you go to one point, and from the right you go to the same point. Generally speaking, one side to the other, and you always start with the more complicated side. Clearly, the right-hand side, RHS, right-hand side, is more complicated. And a good practice is to go with sine and cosine if secant, cosecant, tangent, and cotangent are involved. So secant is 1 over cosine. So this is 1 over cosine squared. So clearly we are dealing with a complex fraction. And to deal with a complex fraction, you are going to multiply both sides by LCD. And obviously, this is cosine squared, this is cosine squared. We're going to multiply everything by cosine squared. When we multiply these two, we just get 1. When we multiply these two, we get 2 cosine squared. When we multiply these two, we get minus 1. Now recall, cosine of double angle, 2 cosine squared alpha minus 1. So 2 cosine squared theta minus 1 is cosine of 2 theta. And therefore, it's secant of 2 theta, because secant and cosine are reciprocals. And believe it or not, that's the proof. Sine cube theta plus cosine cube theta over sine theta plus cosine theta is 1 minus sine theta per sine theta. So clearly this is more complicated. We start with the left-hand side. And we notice the top follows a cubed plus b cubed. A cubed plus b cubed is a plus b times a squared minus ab plus b squared if we factor. So the top becomes sine theta plus cosine theta times sine squared minus sine theta cosine theta plus cosine squared theta. The bottom remains unchanged. These two cancel each other. We put these two together. You don't have to write here. You should see it's 1, but yeah, let's move them next to each other. The answer is 1 minus sine theta cosine theta, which is the right-hand side. Solve sine of 3 theta equals 1/2. Theta is between 0 and 2 pi. How do we solve an equation? Okay. First, I want to ignore the 3 theta, and I'm going to say it's, let's say, x. Okay. Sine x equals 1/2. Now this has two solutions because sine is positive in the first quadrant. Okay, so it's pi over 6. And it's the second quadrant. Pi over 6 is the reference arc. Okay, so first quadrant, the reference arc and the angle are the same. In the second one, the reference arc is pi minus theta. Please understand, this means if you move the theta, theta is pi minus theta prime also. So if pi over 6 is the answer, and that works as a reference arc, the other one is pi minus pi over 6, which is 5 pi over 6. So I want to make sure we understand how it works if we have a single angle instead of multiple angles. So this is it, you're done. If they didn't restrict it to that one, let me just add also this one. Let's say this wasn't there, okay? Then you would say x is pi over 6 plus 2n pi, x is 5 pi over 6 plus 2n pi, and n is an integer, meaning uh, 0, 1, 2 to infinity, to the left side, -1, -2 to -infinity. That's it. So one more time. If they said sine x equals 1/2, these are the two answers from 0 to 2 pi. If the 0 to 2 pi is not there, this is the answer. Infinitely many solutions, we are done. But I want to go back to this question, sine 3 theta equals 1/2. So again, I'm going to repeat because it's important. If the question is what is sine x equals 1/2, give us the answer from 0 to 2 pi, you say pi over 6 and pi over 6. Done. If they say sine x equals 1/2, solve it. And they don't give you the restriction 0 to 2 pi, you find pi over 6, 5 pi over 6, and then you add 2n pi. Sometimes they say 2k pi, and you're done. Now I want to go back to this question. To go back to this question, let me erase my work. Now x equals 3 theta. So 3 theta is either pi over 6 or 5 pi over 6. So how do you deal with that? Here's the methodology that we use. We have to use plus 2n pi. Then we're going to divide by 3, everybody. Let me just divide by 3. When you divide by 3, the pi divided by pi over 6 divided by 3 is pi over 3 times 6, or 18, plus 2n pi over 3. We do exactly the same thing with this guy, 5 pi over 6. 3 theta is 5 pi over 6. We're going to add the 2n pi, and we're going to divide by 3. This becomes 5 pi over 18. This becomes 2n pi over 3. Now, I'm going to erase my work. We are going to use n equals 0, 1, 2. Why is that? Let's go to this. Whatever this number is, you start, in order for you to come up with the answer, you're going to replace the n with 0, 1, 2, and continue until you hit this number and you stop before that. What happens if you use number 3? If I put number 3 here, 3 cancels out the 3, it's pi over 18 plus 2 pi. So let me just show you. If I use 3, this becomes plus 2 pi. So that means, again, you go back to the first one, where n was 0, pi over 18. That's why you look at this number and you say, I'm going to start from 0, and I'm going to go all the way to this number minus 1. So if it's 10, I stop at 9. If it's 20, I stop at 19. If it's 3, I stop at 2. If I don't, what happens? Not a big deal. You see that it repeats. Okay. So again, let me erase my work. So if I put 0, this goes away, I get pi over 8. If I put 1, let me just change this. Instead of this, okay, I'm going to put 18. That means I multiplied it by 6, 12, and pi. It's easier to see it this way. Okay, and I'm going to do the same thing here. Instead of that, 12 and pi over 18. You see what I mean in a moment. Obviously, if n is 0, it's pi over 8. But what happens if n is 1? If n is 1, you have 12 pi and pi, 13 pi over 18. If n is 2, 2 times 12, 24, and 1, 25 pi over 18. We repeat the same thing here. Again, 0 gives you 5 pi over 18. This is gone. If it's 1, 12 pi and 5 pi, 17 pi over 18. If it's 2, 24 and 5, 29 pi over 18. This is how you find it easy. You just come up with a common denominator. It makes it easier to come up with the answer. Solve the equation cosine squared minus sine squared plus sine x equals 0. X is between 0 and 2 pi. So how do we solve that? When sine squared and cosine squared are involved, this one is telling us what to use. You are going to use Pythagorean identity. Sine squared plus cosine squared equals 1. But are you going to solve for sine squared or cosine squared? Because this is sine and this sine squared, you're going to replace this one and you're going to solve for cosine squared, which is 1 minus sine squared. So this is replaced with 1 minus sine squared. And so we have 1 minus 2 sine squared plus sine x. We're going to put it in order, and we're going to multiply by -1. We're going to put it in descending order. So 2 sine squared minus sine x minus 1. This can be factored if, just the way it is, if you have a difficult time with that, let's say y represent sine x. And this way, you're dealing with 2 y squared minus y minus 1 equal to 0, and you factor this one. Okay. In other words, with substitution. Do you have to use substitution? No, but just in case. 2 is a prime number. So we have no choice but to go with 2 y and 1. And since this is -1, just 1 and -1. Okay. And just throw it in somewhere. If I put -1 here plus 1 here, I have to check the middle term. Please understand what do I mean by this one is minus y, this one is plus 2y, and they add up to plus y, and that's not the answer. So you have to change it to plus 1, minus 1, or just directly deal with sine. Okay. It's up to you. Whether you want a substitution or not. In any event, either the first one, 2 sine x plus 1 is 0, or the second one, sine x minus 1. So sine x is either -1/2 or 1. Now, again, I want to erase my work. Now, please understand how we arrive at the answer for this one. If you go with the reference arc, you are going to work with sine x being +1/2, and x is pi over 6. This is the reference arc. Let's call it x prime here. For this to be negative, remember, it is multiples of pi over 6, but in this case, because it's negative, sine is, remember, positive in the first and second quadrant, negative in the third and fourth quadrant. And so if pi over 6 is the reference arc, and this is negative in the third quadrant. Okay. Theta, please understand if I move things, I want to make sure that we can see that. If this is theta, you move this and you get pi plus theta prime, meaning just add pi over 6 to pi, so you get 7 pi over 6. Whereas here in the fourth quadrant is 2 pi minus pi over 6, which is 12 pi minus pi, 11 pi over 6. So that's very straightforward. And of course, sine x equals 1. There's only one answer, pi over 2. So these are the answers here. And this is the answer there. Now, what I want you to pay attention to, let me just erase my work again. The question was, what's the answer when x is between 0 and 2 pi? If we don't have this, then you say, let me just do that and then I'm going to erase it. If this is not there, everybody, then you're going to say plus 2n pi, plus 2n pi, okay? Plus 2n pi. That's what happens. If this restriction is not there, this is missing, that means there are infinitely many solutions. When it's there, let me erase my work. When it's there, that means just a complete cycle from 0 to 360 or 0 to 2 pi. And by the way, they say 2 pi, you have to answer it in radians. If they say 0 to 360, then you would answer it, for example, here 90 degrees. You would answer it accordingly. Prove the identities. Cosine of power 2 plus x is minus sine x. Well, we're going to start with the more complicated side, which is the left-hand side. And we're going to use cosine of alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta. So cosine of power 2, cosine of x, minus sine of power 2, sine x. And of course, cosine of power 2 is 0, sine of power 2 is 1. So we have 0 times cosine x minus 1 times sine x. This goes to 0. This is simply minus sine x. And believe it or not, that's the proof. All right. What happens in this case? Tan theta over secant theta is sine theta. Again, we start with the more complicated side, and clearly it's the left-hand side. Tan over secant. Anytime you have tangent, secant, cosecant, and so on, it's really a good practice to go with sine and cosine. So this is sine over cosine, and secant is 1 over cosine. Clearly, you are dealing with a complex fraction. So we're going to multiply the top and the bottom by LCD, which is simply cosine theta. As you can see, this one cancels out this one completely cancels out this one. The final answer is sine theta, which is the right-hand side, and we are done. Cosine to the power of 4 theta minus sine to the power of 4 theta equals cosine of 2 theta. To prove that, what do we do? Well, obviously, we start with the more complicated side, the left-hand side, which is cosine to the power of 4 minus sine to the power of 4. However, we recognize this as a squared minus b squared, which is a plus b, a minus b. Because remember, 4 is 2 times 2. So we can factor this into cosine squared plus sine squared times cosine squared minus sine squared. I'm assuming no one has any problem with factoring class. So clearly this is cosine squared plus sine squared is 1. So it's cosine squared minus sine squared. And cosine squared minus sine squared is cosine of 2 alpha. In this case, cosine of 2 theta, which is the right-hand side, and we are done. Tan x over 1 plus tan squared is sine x cosine x. Again, let's start with the more complicated side, namely left-hand side. LHS, left-hand side, okay? And we notice that 1 plus tan squared is one of Pythagorean identities, which is secant squared. So we change it to secant squared. We keep the numerator intact. Now again, tangent and secant, let's go with sine and cosine. This is sine over cosine, and this is 1 over cosine because it's squared. 1 over cosine squared. A common denominator, cosine squared. Let's multiply the top and the bottom by cosine squared. Therefore, these two just cancel each other. And this one cancels out the exponent. Sine x cosine x is the final answer, and it's the right-hand side. So that's pretty straightforward, everybody. Find the exact value of the expression and justify. No calculator is needed. 2 sine power 8 cosine power 8. I hope you recognize this as sine of double angle. Sine 2 alpha is 2 sine alpha cosine alpha. So this is sine of 2 times power 8. Obviously, power 8 times 2 is power 4. And that's a common arc, square root of 2 over 2, sine of power 4. This one, we know sine and cosine. You can replace each one with square root of 2 over 2, this one and this one. But again, if you go with the sine of double angle, sine of 2 times 45 or sine of 90, which is 1, it's easier and faster. Sine of 7 pi over 12. One thing I want to make a point of, sometimes when it's in radian mode, it may be difficult to see. You can always change this to degrees to see if you can make up two, common arcs. This is the sum of 3 pi over 12 and 4 pi over 12. 3 pi over 12 is pi over 4, 4 pi over 12 is pi over 3. Okay, and that is common arc. Now cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So 3 pi over 12 or pi over 4, 4 pi over 12 or pi over 3. And as I mentioned, you can change it if need be to degrees so you can easily see the two angles that are common arcs. Okay. 105, by the way, 105 degrees. Having said that, so cosine of power 4, cosine of power 3 minus sine of power 4, sine of power 3. Cosine and sine, both of them are for power 4 square root of 2 over 2. Cosine of power 3 is 1/2, and sine of power 3 is square root of 3 halves. As you can see, this fraction and this fraction, both of them have the same denominator 4. This one square root of 2 times 1 is square root of 2 minus square root of 6. So square root of 2 for this one minus square root of 6 for this one. Both of them have the same common denominator, namely 4. That's the final answer. we want to find the exact value of the expression again. Cosine of power 12, cosine of 5 power 12 plus sine of power 12, sine of 5 power 12. What is that equal to? We are going to look at the sum and difference, and we notice cosine alpha, cosine beta plus sine alpha, sine beta. Okay, so that means cosine of alpha minus beta, cosine of power 12 minus 5 power 12. Pi minus 5 pi is minus 4 pi. So cosine of minus 4 pi over 12. Now, please understand cosine is an even function. So cosine of minus x is the same as cosine x. And so this is the same as cosine of power 3, which is 1/2. Cosine of 105. Actually, believe it or not, it's the same as 7 power 12. We just did that. It's cosine of 60 plus 45. We are going to use cosine of alpha plus beta. So cosine 60 cosine 45 minus sine 60 sine 45. This is 1/2. This is square root of 2 over 2 minus. This is square root of 3 over 2. This is square root of 2 over 2. And again, both of them have the same denominator, namely 4. This one is 1 times square root of 2 is square root of 2. This one square root of 2 times square root of 2 is square root of 6 minus. So the final answer is square root of 2 minus square root of 6 over 4. That is the final answer, everybody.